Hey folks, welcome out here on a great, what is it, Tuesday? Wednesday? We weren't here yesterday, were we? Some of you are saying, where were you, Ernie, yesterday? I had to think about it for a minute. Yeah, we are on a Wednesday today here, and we had some things going on here in the studio, had a few things that had to be taken care of, so we were off yesterday. But I hope you enjoyed your specialized segments time. We're going to have another specialized segment on Friday, but we're going to be live today and tomorrow. So just get those math questions ready, which means hopefully you've got some good ones waiting for us here today. Call us at 844-686-2378, and we will have a phone operator. And by the way, I'm Ernie Roberts, and I am your host for this afternoon session of Mathline. And we're glad you've tuned in. We definitely are. But now we want you to call in. All right, that number again, 844-686-2378. It's toll free. Call us and ask some questions. Let us look at some things. We had some interesting problems that were posed to us on Monday. We're going to go back and look at those, but hey, we want to hear from you guys too. So give us a call and let's go to that crazy problem of the day. We have 11 less than the quotient of a number and 3. So we're talking about a number divided by 3 is 18. We're going to look for the number. Once again, 11 less than that quotient of a number and 3 is 18. So let's see what's going on here. Multiple operations here. It sounds like we're doing a less than moment, which so you say, does that mean we got that arrow pointing left or right? No. That's not what that one's about. This is a subtraction situation. And so we want to make sure we write that question up correctly, have it going for us good. And we're also talking about quotient, which means some division going on. So subtraction and division in the same problem? Oh my goodness, multitask, folks, time to multitask. So let's see what we're going to do with this thing. First of all, I have a representation of the number. We're going to let n be equal to that number, all right? We're going to let it go there. Now, keep that in mind. What are we going to do with that? According to this, we're going to take the quotient of that number and 3, all right? So we'll go ahead and make a little note of that. There we go, n divided by 3. By the way, fraction is the way we write division. Absolutely. If you've been watching Mathline a lot, you hear me say that almost every episode. But it's one of those things that if we can get over that hang-up, fractions are a little bit easier to deal with if we just think of their division, all right? In this case, we're going to take a number, we're going to divide it by 3. Now, some of you are saying, well, Ernie, don't you need to deal with the 11 first? Well, that's a good question. What does less than tell me? If I say something's, let's just say 11 was less than some number, period. What would you do? You would subtract the 11 from the number. In this case, we're going to say 11 is going to be subtracted from the quotient. So here's our expression. We got n over 3. Everybody good on that? Hold on to that thought. Then we're going to do the less than part. That's the subtract moment right there. Now you say, well, Ernie, when would you put the 11 in the front? It's sort of like you're reading backwards here. Well, the less than tells me I need to switch direction a little bit, all right? If I had just had the word less, 11 less the quotient, then it would be 11 minus, okay? 11 minus n over 3, which make a different problem, obviously. But we have this. This is our story. And what did I put minus 3 there? Because I'm all hung up on the 3, am I not? Let's get that right, okay? So we go. Here we go, 11 and 11. So thank you, folks. Let's just write that again. That looks awful. All right, let's do it. 11. We're going to subtract the 11. I got all excited about that 3. Let's just say forget that. All right, everybody got it. Now, what are we going to do with that? There's a big word is right there waiting for us. Equals. And now we're going to put 18. I think we got everything in line now. And the way we're looking at, again, this is just saying some number divided by 3, then we subtract 11, we will get 18. And that's what our wording is telling us to do here, all right? So everybody good so far? Now that I've corrected myself twice? Yeah. Now, let's see where we go. Add, we're going to get rid of the 11, right? So we're going to add 11 to both sides. We'll put a plus 11 over there. We've got n divided by 3. We're going to have that equaling to 29. My goodness, what in the world do we do now? Well, we're saying some number divided by 3 gives us 29. This is where things get a little bit easier, all right? We just need to multiply our 3 over there into the 29. So I'm going to say let's multiply this side by 3. If we do it to the left side, we got to do it to the right side. That's called the multiplication property of equality. And I believe that's going to give us n almost 90. If it were 30 times 3, it would be at 90, but we're 3 less. So let's go with 87. There's our number. Quick check. If we take 87 divided by 3 and we subtract that 11, do we come up with the number we're looking for? In other words, 11 less than this value here, which happens to be 29. So we're saying 29 minus 11, does it give us 18? It surely does. We get 18 to the left, 18 to the right, check, check, and there you go. So it's always good to check out those numbers. And does the answer make sense? Yes. We're saying basically if we take the quotient of, what was it, 87 and divide it by 3, we're going to get a value, and we're going to subtract 11 from, because that's what the 11 less than says. We subtract 11 from that result, we will get 18. So there you go, a little bit of putting words into symbols today. And hopefully, I know we had some folks on Facebook that got the right answer on it, and thank you for tuning in on that. We will go with another problem. We may have 2 tomorrow. Who knows, all right, because we skipped out on yesterday, so we'll see what happens on that. But anyway, thank you guys and appreciate you on the Facebook. While we're at it, let's go ahead and give Facebook a plug. What's that all about out there? We want you to like us, love us, and above all, share us. Share that problem of the day. Share our postings. What is our specialized segment going to be on those days we aren't live, okay? So, and once again, that's all on www.facebook.com/with the Mathline online, and some good things going on there. All right, I said I was going to go back and hit some of the problems we had in the Monday show. It was a couple of days ago. One of them, one of our viewers called in, and I think it was Chris, and had a great problem. And one little thing was catching and glitching on us here. What's the rule for a certain set of numbers? So let's go back and take a look at it. So you're going like, whoa, Ernie, what in the world was all of that? I should probably just put a little cover sheet up here. We'll look at it piece by piece. Lots of scribbling, lots of scratching here. First of all, the values we were given for x were 0, 1, 2, 3, and 4. And we were also given some y values of 0, -1, -1 over 8, -1 over 27, and -1 over 64. And we were to come up with some sort of a rule, an expression that would cover all of these values. Well, we found a rule that worked for the last 4, but 0 and 0 just totally blew it. Okay, it totally messed it up. And honestly, I think the way this thing was set up, they should not have had 0 and 0 in the problem there, all right? Because 0, any other number is going to work fine in this rule, but 0, 0 did not follow the pattern. All right, so you say, well, is there a better rule? Not really, okay? There really is not another rule that what we're looking for. And it was meant to be something simple, so I think the problem may have gotten set up. But anyway, let's take it and look at it from a standpoint of the graphic relationship, because we started thinking, and let me just go back through the thought process here. We started thinking about, okay, how about x cubed? Because our viewer said, well, I know that 2 to the third power is 8. I know that 3 to the third power is 27. 4 to the third power is 64. She saw that pattern. So we said, well, all right, let's start with the parent function, we call it. Y equals x cubed. It's not the answer here, but it's the parent function, is where we start. We also notice that it seems to be an inverse relationship. So it's 1 over, and by the way, 1 to the third power is 1. So that's where we got a -1. It works well. The negative will pop up in just a second. I'm sorry, let's go back to just the fact that we're going to look at it as being an inverse or a reciprocal situation. And that came out to be 1 over x to the third. So we went to this step. We said, okay, we got cubes and we have their reciprocals. So it'd be 1 over. All right, that's the deal. But then we have one more thing incorporated. We started out positive with x, but ended up negative with y. So we went and added one more element. So this became the rule. This became the rule that works for all of these. Now, the one catch is, 0 cubed is 0. Amen. I know that. You know that. But when we write 1 over 0, we don't get 0. We write -1 over 0. We don't get 0. We get an infinite number. I mean, it just goes, basically, the calculator said we can't do it, and it's basically undefined. It's an undefined situation. So we want to look at this from a graphic standpoint. So what we're going to do, if we'll go to the graphing calculator with me, guys, we'll show you also what went on there and why it won't work. All right, our rule won't work for all 5 points. It's going to be pretty straightforward if we will go along with it here. Let's go to the stat key here. And what happens with this, we are allowed to put in some things for lists, and this can become ordered pairs, all right? So we'll pop in and edit. And what we did, we put in list 1, we put our x values, 0, 1, 2, 3, 4. And on list 2, we put in the y values. We had 0, we had -1, and we put in a -1 divided by 8 for this one, and the calculator automatically sends it to a decimal. We put in, what was this one? It was -1 divided by 27, which certainly won't come out even. It's not going to terminate on us. It's going to go crazy. And as a result, the calculator rounded it off somewhat, all right, to, as you can tell, it looks like 37 thousandths. And then, and by the way, it's all negative, notice, which we were saying was going to do. And in this case, we also popped in, goodness, we put in a -1 divided by 64, and we got this, which was obviously a little bit smaller in terms of absolute value, but, you know, it's a negative also, and that was where our values were. So the next step, I said, let's graph these. Now you say, Ernie, how do you graph lists? Well, here's what we do. And let's go back over here. We're going to hit the second y equals. This is a great thing about the graphing calculator. And you've got what we call stat plot. So what I did, notice I said second, follow my cursor, and y equals, which is still highlighted up there in red, because what that really did, that gave us stat plot in blue. When you hit the blue button, which is second, it takes you to the blue, even though we're getting a red color. I know it gets kind of crazy, all these colors. But there we have it. Now, take a look what we've got here. We've got a lot of plots to work with. We're going to turn the first one on, all right? So I'm going to press an enter there. And I've already turned it on for you, but I want to go through the process. We will press enter because so many times I get all the other stuff in there, I forget that I have to turn it on. It's not like, you know, it's an infamous joke about, you know, the computer. Do you remember to turn the on switch or whatever? But yeah, we got to do that. Got to remember that. And then we'll cursor down, and we're going to pick this little guy right here. I've got flashing. It's getting right before your very eyes. This is what we call a scatter plot. And it's just going to graph a bunch of points, okay? So I'm going to try to connect them. Not going to do anything. If I try to connect them, I've been crazy on these. I guarantee you the 0, 0 would really have a strange-looking situation, would way out of kilter. Notice we got list 1 and list 2, which is great because that's our x, that's our y, and we're going to spot it with a little nice little box there, okay? So please, that's what's going to happen. We're going to take a look at it now, and the color is red. Isn't that nice? So let's do this. And to do that, to see what it looks like, we're going to use a little trick here. It's called the zoom key. Look where I am here. I'm going to hit zoom, and we're going to go to number 9. We're going to do a stat because stats are edits. Edits are data. All those good things we've sent in there. So let's see what happens. And we've got these 5 red dots. Hopefully you see them on your TV. There's 0, 0. Then we've got this little guy down here. Here comes our other one. That was our 2, -1/8. This is our 3, -1/27. And last but not least, notice they're getting very close to that axis because they're getting smaller and smaller in terms of their absolute value. They're getting closer to the x-axis from the negative side. And there we have it. That's -1/64. Never quite gets there, but it gets real, real close. And eventually it's going to look like we did. But notice something here. And you may not see it right now, but there is a pattern developing here. You say, really? There is. We're going to show it to you. This looks bizarre. This is not really patternistic. It's kind of out of range, out of whack there, okay? So let's see what we would do for our rule. Remember our rule that we said? I'm going to go back over here. We're going to go to the y equals and see what happens. We're going to plug in our rule and see how that graph looks because that's what these things are. They're ordered pairs and they should fit some sort of a rule, all right? Everybody good on that? Nod with me? Yes, you do. So how about it? We had a -1 divided by x. Where did x go? There's x right there. And we're going to raise that to the 3rd. So we use the exponent key. Right there's the exponent key. Can you see my cursor, everybody out there? There it is. Exponent key. And then it allows us to have a box. We fill in the 3. That's the formula that Chris and I were working with. Wanted to see what happened. So let's hit the graph. I hope she's watching today because this may make a little more sense today, seeing it again. And look at it. It pretty much hit. You say, well, Ernie, it looks like it tried to avoid. You got to remember, those are round-offs a little bit. So in some cases, they didn't quite exactly nail it perfectly, but it's pretty close, all right? In other words, they do have a pattern going here. But look who got left out. 0, 0 doesn't belong there. You say, well, where does 0 belong? It looks like it looks like it's getting bigger and bigger, doesn't it, as it go down that hill? And maybe it gets closer and closer. Does it ever get to zero? This looks like it's getting close to zero, but it never really does. So what we're going to do, we're going to open up the graph a little bit more. All right, everybody with me? Hold on. And we're going to open this thing up. So we're going to go back to a standard look. You say, what? Can you just do this? It's the luck of technology. It's also the luck of what a graphing calculator will do for you. It can give you a, where we go, there we go. It can give you a close-up feel. We can also go back and see how does this look in the grand scheme. So let's go zoom and we'll hit 6. We didn't do this on Monday. And there is another story. There is another story here. Notice it keeps going on, and notice this thing keeps getting closer to the y-axis, which is where x is actually equal to 0, but here's our point, still not doing very well. I mean, it's basically kind of pretty up there, but look what's going on the other side. Basically, it's a mirror image across that origin, all right? We're seeing this one go this way, this one is working the other way. So my question is, if we were to trace, oh my goodness, you're all ready to trace? I'm ready to trace. Let's see what happens. And by the way, it's saying, are we going to go with the red one? No, we want to go with the line, because the line is our big guy right here. And look what happened when he had 0. There is no y value. Folks, it's undefined. It's undefined on the blue. Now, yeah, we can find it on the red, but this isn't the red curve. We're worrying about blue. We're worrying about the blue. Where did it go? Right there it is. We're worrying about that blue piece right there. So, come on, cat, little mouse, quit going crazy. So that's what happened when we started to trace it. Now, if I put in 1, everybody ready to see what happens when we get 1? Let's put a 1 in there. And press enter. That's what we thought it would be, -1, okay? If we put in 2, we enter. There it is, that -1/2500 is right where the red dot said it should be. I can go again. Why not? Let's put a 3 in there. And see what happened. This gave us a little bit more, but remember we said it's rounding off. Basically round off. It actually started repeating itself. I told you it was going to repeat. And there it went. And let's go one more shot here. How about with 4? This one should terminate, but a calculator can only get basically 3 decimal places usually on these things. Let's hit an enter. Now here we go. We did end up. This one did take us out to a termination point. And that's why there's a little bit of discrepancy between the blue line and the red point. And we saw it close up. All right. So as you see it here, my still thought is, I said x had to be greater than 0. Well, in looking at the part of the graph we had there, it's true. We could also have x less than 0. The only place we cannot have x is at x equals 0, because what happened again? For those of you just tuning in, what's he doing? He's going to try to get to 0 and trace, and what happens? It disappears. It becomes undefined. So back to our problem here. Let's just go back here. So I'm going to say, yeah, where x is greater than 0, but also we could say x is less than 0. The thing is, under no circumstances, we have to say this. We're going to say x equals 0, nay, nay. So that's the case. We cannot have an x equals 0, so I think that's an error in the data table there. So going with the rule, it works great for these 4, and we can continue that pattern right on out there, and it would still fit on that curve. So a way to see it physically. That's kind of cool, I think, to see our numbers in a picture. Sometimes you think numbers are just these abstract things. They are in a picture. Now, I've babbled enough, I guess, here, folks. Let's see if we can get some phones ringing, all right? Some of you are going, I hope you haven't turned off the set yet. But again, I want you to see that some of the things that we look at, some of the things that seem real obvious, sometimes the things blow our mind. When we try to divide by 0, it doesn't work. It can't happen. So there you go. But what can work is you guys calling us, all right? And let's go with 844-686-2378. And I want to take another look while we're at it here at Monday's problem of the day, or a variation of that problem of the day. Now, I gave you a hint in the problem of the day. Some of you said, that doesn't look like the problem of the day, Ernie. It was close. I said Alice had some quarters, and he had $5.15 in nickels, all right? And if he has $7.90 total, how many quarters did he have? Well, we found out he had 11, all right? That was pretty easy. So what if I gave you this problem and didn't tell you how much money he had in nickels? And I told you he had $7.90. How many quarters does he have? Could we figure that out? And some of you are going like, well, what if? And that's where we start doing what if. What if we knew how many nickels? Would we always get the same amount of quarters? No, it's going to vary. As you change the number of nickels, it's going to have an effect on how many quarters if we're going to have $7.90 total. So what we need on this one, my friends, I want you to notice something. If there are two pieces involved, two unknowns, because we don't know, we need two clues. We need two things to help us, all right? By the way, yes, that's right. The other day, the $5.15 was a big clue. Absolutely. And then we were able to go right into it. That's all we need. And we had a total. We knew that. Two things, important things we knew. Here we need another number. And I'm going to provide us with one. And I hope it was from what we did the last time. I believe we ended up with 114 coins. So let's suppose I add this mix to it. Now we have two clues that give us a specific restriction, a specific focus, if you will. Isn't that great? You say, well, I don't know yet. So here's what's going to happen. I'm going to let X equal the number of quarters. I'm going to let, well, how many nickels do I have? If I don't know how many, and some of you say, Y, use Y. And that might be a good thing to do on this, all right? But I'm not going to do that today. You say, Ernie, don't do that to us. We're going to use 114 minus X. Now you say, what? That's going to be the number of, what do we got here, nickels. Now, why do I do that? Because, folks, let's say I have 70 quarters. Then what does that tell me? I subtract 70 from 114. Oh my gosh, that's that less than moment, isn't it? Just subtract 70 from there, and it's going to give me a number. What is it, like 44, I think? I got an answer. It's not the right one here, but I've got an answer. You see how I did it? I subtracted. Let's say I have, what if I decided I got, 10 quarters? I subtract 10 from 114 to figure out how many nickels, right? And I could play this game until I got the right combination. But we're going to use these two expressions and the values of those coins, and we're going to work through it and hopefully get through pretty quick, all right? So let's do it. Let's see. We said quarters was going to, so quarters are worth 25, so I'm going to put 25 cents times X. Got that? Is that good? Now nickels, how about it? Plus, what are we going to do here? Nickels are worth what, 5 cents, right? So 5 times 114 minus the X. So we're going to, once again, so as you're tuning in, says, wait a minute, what's that 114 about? I'm giving it to you, okay? We needed to have an extra clue. And what are we going to have in the end? According to this, we're going to have $7, I'll get it right in a minute. Switch my eye motions a minute. $7.90. How about $7.90? I think that's what we started with. Yeah, $7.90 there. So let's do some work with this. How about it? We got 25x. That hangs well. Let's do that on the calculator. Make sure we don't make a decimal mistake, right? How about 114? We're going to multiply it times. Got it. We're decimalizing here. And let's see where that takes us. It takes us that's 570. If we're talking money, right? We are talking money here. So there's 570 minus, how about it, 0.05x equals whatever, okay, 790. I knew I could get that. All right, so now let's do something here. Let's put these little guys here together, and let's see where it's going to go. We're going to end up with, you can put that also 2/10, we'll call it 20 hundredths, and we got $5.70. We're going to move it around. How about it? Let's see what happens. We got 790, and we're going to move the 570. And I think we're going to have 20 equaling to, it looks like what, what is that, 220? And you know what happens? We get X equals 11. Oh my goodness, X equals 11. That was our quarters, wasn't it? And that's how many we had the other day. Quickly pop in this value. We got 103. Another way that I could pull the problem, okay? And folks, it was very simple. This time we didn't know the nickels hint. We needed a little help, all right? And that's how we worked through it. But it's the same idea. Take the quarters plus the nickels, $7.90. And that's how I want you to think a little bit. When we do a little bit of reasoning, we do these algebra problems. I know we have a lot of parents who watch this. We have students who watch this also. High school, elementary school, middle school, all sorts of things. What you learn, the processes, still carry over in the algebra. It's still all about adding, subtracting, multiplying, and dividing. And that's what you deal with here. All right, that's what we've done. Absolutely. Just made some interesting numbers along the way. And talked about money. What more can you ask for? Hey, thank you for tuning in today. We got to catch up a little bit on our problems of the day. We'll be back again live tomorrow. We'd love to hear some calls tomorrow. So get you some problems out there. Think of some things that you can call us in at number 844-686-2378. And we will see you, as always, we will see you once again next time.